Hello, I'm Dr. Rosemary Francis, Chief Scientist for HPC here at Altair, and today I'm going to tell you about PBS Professional and our support for containerized workloads. You find containerized workloads across the whole high-performance computing spectrum, but particularly in the areas of hybrid cloud and machine learning, where the benefits of portability and reproducibility have really been embraced within these communities. In the past, there's been a lot of hesitance to take up containerized workloads and to support containerized workloads in HPC environments, but I think a lot of those have been resolved, particularly with the integration with workload managers. So I'm going to be talking a little bit about how the integration with PBS Professional solves those security issues. So first of all, what does the experience look like when you start running containerized workloads in PBS Pro? There's no need to do a Docker run. PBS will automatically instantiate the image and launch the job script inside the container. All of that is handled for you. And that's supported across a wide range of different job types. So obviously normal batch jobs, as well as interactive jobs, jobs that require GPU acceleration, scripts as well as binaries, as well as MPI jobs, other multi-node jobs. And we also support the file stage in and stage out mapping inside the container as well. So it's all the essential parts of the user experience just work. We also provide true reporting of the entire container resource usage, so both the container and the C group that controls it. We report memory, virtual memory, CPU, and so on. So now looking at the security piece. So historically, it was necessary for the users, the job submitter, to be part of the Docker group, but that isn't required when using containers integrated with PBS Pro. The system administrator has the ability to control bind mount options for files and directories, so users can mount the files that they need, but they don't get access to anything else that they shouldn't. You can use the user login to authenticate against the image repository. So you can control which container images users have access to. Containers are launched via non-root credentials. So our customer, there's a customer quote here. We hear it all the time. That they would not be using Docker on their systems were it not for the PBS Pro handling of Docker security. So this is really vital in making containers a viable solution in HPC systems. For those of you not familiar with Enroot from Nvidia, it's a way of running Docker containers in an unprivileged fashion that integrates directly with all of your existing workflows. So it's a very popular way of running containers, particularly when using GPU components. There's a white paper where you can read about it in more detail, but we do all the essential parts of the setup and cleanup of the enroute directories, as well as the job script start and stop commands. So how does that integrate with AI and other popular machine learning workflows? Applications such as the TensorBoard web interface or Jupyter Notebook, they have got web interfaces that need to have access to the outside world. And so at least for single host Docker containers, PBS Pro does support port mapping so that those services can get to the outside world and be used in exactly the same way you would if running on your laptop or in a non-containerized environment. So as you can see, the port range is configurable by the admin. So again, you're not giving users access to any port. You can really lock down what they are able to do. So for containerized workloads that use GPUs, it's often necessary to have access to the shared memory size. Normally that will be done via the Docker argument. Again, PBS Pro supports this, so administrators can set up a container args allowed whitelist of Docker arguments that users can control. Users can then set the PBS container args environment variable to pass that option into their PBS Pro containerized workload. So this means that they have access to the arguments that they need to run their job, but they don't have access to any other arbitrary arguments. And of course, storage is absolutely vital for HPC workloads. This is something which is done in Singularity automatically, but to mirror that support in Docker containers, PBS Pro will automatically add the job owner to all of the host OS groups inside the Docker container, which means that the user will have access to all of the shared storage they need from inside their containerized workload. So in summary, PBS Pro makes it super easy to run AI workloads and other HPC workloads in containers. The integrated support means there's no need to modify workloads and change your job scripts when you containerize them. We support single multi-node MPI jobs. We support GPUs. We handle a lot of the security and system administration issues within PBS Pro so that the user doesn't need to be part of any container group or have root privileges. They get access to their storage, the images they need, and the user credentials without handing them the keys to the entire kingdom. You can really lock that down. And we have whitelist support so that you can control which options they are allowed to change for their containers and which options they can't. Finally, the port mapping makes it easy to access your Jupyter Notebook, TensorBoard, and other web interfaces or interactive interfaces using within your job, just in the same way you would do for any other workload. Thank you for listening. Stay on the channel to see following videos demonstrating these capabilities with real life jobs.